CircleCI security breach, GitHub solution for encrypting the columns in the database, and more than trillion messages a day at CloudFlare in the architecture weekly number 50. Yeah, I can't believe we reached that number, but it happened, so let's get started. And the first highlight for today is the CircleCI unnoticed holiday security breach. CI/CD pipelines literally have only two jobs: build and stay secure, and CircleCI failed his job this time. So during the Christmas and New Year's holiday, there was an accident, and the CircleCI sent a letter to their customers that they need to rotate and replace all their secrets that were stored in the platform. Sounds horrible to every client, so basically if you are one of the CircleCI, go and replace your credentials and other secrets there. And while you're doing that, follow Jorali Oresh publication in his Pragmatic Engineer newsletter covering how this security breach happened, the comments from the company itself, and some other aspects of the incident. As we started with the security topic in this issue, we continue with the GitHub's conversion of unencrypted database columns to encrypted ones. So obviously, as we just learned, it is very important to store your data securely, and one of the ways to do so is to encrypt them, right? But if you don't encrypt them and use some short keys for encryption, you want to upgrade your security measures. That means that you will be converting the plain text columns to encrypted ones and previously encrypted columns to a new level of encryption. Here GitHub shows how they do that and what issues they actually face. So for example, if you have several encryption keys and different methods of encryption and decryption, how do you extract the plain text from the encrypted columns? And the reply to it is that you try several times, and if none of your keys work, then you just throw an error. So read the journey from GitHub and how they leverage Ruby's active record thing to do the job. And the last in the highlight section of today's issue is using Apache Kafka to process 1 trillion inter-service messages. So CloudFlare has been using Apache Kafka for more than 8 years. They processed over 1 trillion messages over those years in their general purpose cluster. But they have other clusters that are processing trillions of messages per day. So how CloudFlare are handling those? Well, first of all, they have a lot of internal tooling, and they have even several versions of those tooling to support this increased load. One of them is the connectors library, which allows to build data transformation from and to Kafka in a declarative way. They also leverage strict schemas for easier integration, and of course they're doing a lot of observability work to ensure that their clusters are alive and working properly. Follow the article for the details in CloudFlare engineering blog. Welcome to the follow-up session, and the first one is the Simon Brown's talk about the lost art of the software design. So once the agile came into the place, the people just stopped doing the upfront design because it was somehow not agile. And then they started doing like very little portions of system design, and that was going from one extreme to another. Simon Brown in this particular video explains why you shouldn't do so, but rather doing some part of the upfront design and then iterate to a better version. In this very detailed and indeed funny talk, he shares the examples of architecture katas, the diagrams that people come up with during the upfront design phases, and so on and so on. So learn the important lessons from the person who created C4 model. It's always nice to watch some fancy video or read some short blog post. But if create, update, delete applications is not the only part of the job that you need to do, but rather building more complex system, you would like to read some papers as well. And Stack Overflow blog includes a short article on really that you need to pay attention once in a while to a paper or two to understand the underlying fundamental problems of computer science that we address while doing our system design, be it distributed consensus or time synchronization or replication, etc., etc. And of course, if we speak about the papers, I need to remind you the fundamental paper about time clocks and ordering of events in the distributed systems, written by Leslie Lamport himself. So this article goes through about ordering things, about physical logical clocks, introduces the concept of happening before, and includes some proofs of the theorems. I'm sure you will like it a lot. Okay, next one is about data inventory. So for many e-commerce applications like selling shoes or maybe delivering the food like Bolt food, it is very important to have the appropriate amount of inventory in order to tell their customers the truth about the stock availability. So DoorDash in their engineering blog shared an article about how they implemented the CDC, change data capture mechanism for their inventory. So the exact problem that they had is that once anything is changed in the inventory table, they need to propagate those changes. One way of doing that was to just supplement the code that changes this table with the appropriate messaging to Kafka. However, the code paths can be in multiple numbers. That means that they require a better solution. So what they came up with is the native CDC solution for the CockroachDB, which they're using for storing their data and sending the messages automatically to Kafka. Follow the DoorDash engineering blog for the details. Okay, and the next one is running enterprise workloads at scale with next-gen IaaC platform, which stands for infrastructure as a code. So Intuit company, which is doing, tax reporting and all that stuff, they were an early adopter of cloud technologies. They started with EC2, Kubernetes, Lambda services, and many more. And once IaaC frameworks appeared, they started to use CloudFormation. When they started doing that at scale, it came up with their own problems. For example, if you were describing a lot of virtual private networks, the code would look like this and it was really unmaintainable. So they contributed to the Amazon Cloud Development Kit in order to make it more feasible and easy for the development and appropriate usage. So follow the Intuit's blog for the details. Okay, and the last one for today is PostgreSQL vacuuming to optimize database performance. What the hell is the vacuum and what the hell is multi-version concurrency control? So when you write data to the PostgreSQL database, it doesn't overwrite the old value in a row, but instead it inserts a new version in a row with a thing that is called transaction ID. And this helps to ensure the database guarantees. So when we try to read a value, the database is able to understand for which version of the snapshot this row refers to and be able to provide proper consistency. However, the historical data starts to occupy some space and you want to delete it eventually. So this is what vacuuming is for. Here in the Persona blog, you will see the explanation of this MVCC, the vacuum thing, and how to configure it properly in your PostgreSQL database. Okay, thank you very much. That's it for today. I hope you enjoyed the newsletter. In such a case, please leave a like and of course don't forget to subscribe to the channel. Or you can subscribe at the blog itself, and of course the link to the text version of the newsletter is down below. Last week I also published the third video of the architecture reading series with the chapter number 3 of database internals. My patrons and boosted subscribers already have the access to those videos, so if you want the early access, you can support me as well. And for everybody else, wait for several days, it will become publicly available. Thank you very much and see you in a week.